Welcome everyone. This is the presentation of the product and the project the startup made for the Hackathon Gen OS 2025. This is Team LataMLOperators is the name that we came up with. So we are going to discuss the team members later on. We're going to start with the idea first. So our project name is called Petrol Chain AI. So it's a AI agent based on solving some of the consultancy market issues that are developing now in the energy industry, and also to be able to develop and revolutionize the production process overall. So our main concerns were about redefining the traditional industries, modifying how the industries work as of now with cutting edge technology using agent AI, and of course using agent OS technology, and delivering exceptional customer value. So just to go forward, I just want to also share the pitch deck that we have. We're going to share this with all the requirements, the GitHub and the idea. But I wanted to first discuss the idea and how this problematic came on. So our challenge was to navigate the opaque energy market. So using Petrogen AI, we're going to give both consultancy firms and either from small to big producers like government industries and so on, the ability to have a um, helper basically that will be able to analyze things. Here's the diagram of the multi-agent interactive. So we have an economic input agent focused on doing the analytics of the data. Right? It's going to focus on analyzing both the prompt of the user and the analytics of what we have in the current store database. Then we have the modeling agent, which is the one that has tools to call the machine learning models that we implement. It depends. It will analyze the economic input agent, will tell the modeling agent what models it will require for the user prompt, right? It all depends on the user data and the prompt. Then on we have the MCP with Cloudera. So this MCP works by having different tools and usages that will allow us. We created a warehouse in Cloudera, basically SQL is where we're keeping our data that we found on Pemex data from 1960 up to this year. So we store that on the cloud to services, and the MCP agent is in charge of just giving us that access through MCP. So it contacts Cloudera agent and accesses the data to finally go back to the modeling agent, and then the modeling agent will show the data to the master agent. The master agent is the one that is already implemented in the agent OS. We modified it just so it could work for our usages. So I'm going to go. So to start with, we're going to give it a similar regular prompt. So here we type, hello, can you introduce yourself and explain what you're supposed to do? So here you can see that it will respond, especially, and that is specialized in informing about oil field production and energy sector. Then we ask what kind of data can you work with? You can see that it's specialized in using all production data sets. Then we're going to ask, can you tell me exactly what you do with the date and the time series data? So here we just start seeing one of the implementations that we did, specializing the agent and contextualizing the agent for this case on Pemex oil production. Now that we have checked that it understands the data from the database that we are using, we can ask things like, give me the production on different fields. So it will give you the stack value according to the model of production overall. But then later on, we're going to see how we can use it for really complex questions, like, for example, the next one, which is going to be the predict hydrocarbon AMD production, which is an important marker on oil industry, for the fields app for a defined time frame that we don't have data on. So for the next 12 months. So what's future data and how this prediction looks like. Now that we looked at how our solution works, let's go ahead and show you a little bit more of what we implemented. So we used different models. We used linear regression using Meta's Prophet machine learning model for forecast prediction. We used also implementation for LightGBoost that were tested, and we found some important data analysis. So we found that our model were able to predict and demonstrate 92% accuracy in the predictions of forecasting cap of who we are. So the team is composed of two people. So we made it we are both engineers and ML AI engineers from Colombia. First one is Diego Casabuenas. You can find the LinkedIn on the split deck on the section right here if you want to interact with him. And then there's me, Joshua Olave, which I'm also we're both really striving forward creating technologies and demonstrating the usage on the AI technologies overall in different markets. All right, so thank you for taking the time to see this presentation, and